Hello, grade 10 science. We are going to start talking about motion, how we observe it, how we describe it, how we develop laws to predict and tell us what we should expect or what we think is going to happen. Eventually we're going to start talking about Isaac Newton and his 3 laws of motion, which is kind of our most current understanding. But before we get to Isaac Newton, we like to talk about how the idea of motion has developed over time. So the first guy we talked about is Aristotle. We've talked about Aristotle quite a few times, and he also looked at motion. The way they looked at motion was they looked around them, they made observations, and they tried to describe what happened in their observations. The 3 things that Aristotle came up with, I have listed here. You guys have it in your notes. I just kind of want to do a quick demo on what it means. So the first basic thing that he saw was if you push on an object, it moves. If you don't push on an object, it won't move. So push equals move, no push equals no move. So what does that mean? I've got this desk here. I am not pushing on this desk is not going to move. Unless something miraculous happens, that desk will not move unless something happens to it. So if I push on the desk, it tends to move. I stop pushing, it stops moving. That is the first thing that Aristotle described. The second thing is what he called natural motion. So in natural motion, he observed this phenomenon. You take something, you let go of it, it drops. The way they described it was they said, well, obviously look around us. What do we see? We see the universe. We are on the universe. The earth is the universe. The earth is the center of the universe. So when something drops, they said it is dropping to the center of the universe. And he called that natural motion. Obviously, we know now that the earth is not the center of the universe, but he still had some good ideas here. He was more so describing gravity. Yeah, his natural motion things drop to the center of the universe, which was the center of the earth. The last thing he talked about, I like to call it projectile motion. We know if you push on something, it moves. If you don't push, it doesn't move. But then how do we describe this event? I threw an object. The only time I'm pushing on these objects is when it's in my hand. So here to here, I'm pushing on it. Therefore, that's why it moves. As soon as it leaves my hand, though, it keeps moving. So to describe why he thought that happened, he came up with the idea that when an object is thrown, the air that it's going through is being pushed out of the way and then coming back in behind. So the air that's being moved out of the way is going behind the object, and it's actually that air pressure or that force that's causing the object to keep moving forward. It's not the case. We have found out why it is now, and we're going to talk about that a little bit later. But that's how Aristotle. That's how Aristotle described why a projectile keeps moving forward. That the air moves in behind and keeps pushing it forward. Now I got to go grab my stuff that I threw. So Aristotle described all that stuff. It was awesome. People thought he was really smart. Then Galileo came along. Galileo wanted to describe motion a little bit more, and what he decided to start talking about was this idea of inertia. So inertia is a property of matter that causes it to resist a change in motion. Basically, an object wants to do what it's already doing. So an object that's staying still is going to stay still. An object that is moving is going to stay moving. And it's the inertia that describes how hard it is to change that motion. How hard is it to change an object that's sitting still to make it move? How hard is it to take a moving object and make it stop? They eventually found out that the object's inertia depends only on its mass. So a heavier object has more inertia, a lighter object has less inertia. And this makes sense. I would much rather make this little light marker move or throw this across the room than throw an entire table across the room. Because the table is heavier, has more inertia, it is harder to make its motion change. Let's see what else we have on this sheet. We have a couple objects here. In your notes, we have a piano and a toaster, comparing the piano and the toaster. Even though these are both sitting still, they're not moving. To change its motion, we want to make it move. The piano has more inertia because it's heavier. The toaster has less inertia because it's lighter. When we're looking at the semi versus the mosquito below that, the semi has more inertia because it's heavier. It would be harder to stop a semi that's moving at 110 kilometers an hour than it would be to stop a mosquito that's moving at 110 kilometers an hour. Think about it. What would you rather have come and hit you on the highway? A semi or a mosquito? Personally, I think the mosquito would be my choice. Fantastic. The big takeaway from Galileo's inertia: property of matter causes it to resist a change in motion, and that an object's inertia depends only on its mass.